A pleasant day to the viewers of this video. I created this recording as a supplementary material for more example problems on basic integration. So I will present here three examples, and I want you to go over them and probably include this as part of your seat work. So the first item that we're going to solve is the integral of 4x squared minus 5x plus 8 with respect to x. So if you look at this one, I hope you were able to decipher in your head or have an idea in your head that what we're going to use here for the entire examples is the basics of power rule. Um, the power rule of integration is that you're going to add the power of the exponent by 1 and then divide it by the sum of the exponent and the 1 and then include the plus c. So again, one of the things that you have to take note also here is you have to do integration term by term. Okay, term by term. So there's no bulk integration. So you have to perform power rule for each of the terms that you find here in the problems. So you have three terms here. So we're going to apply the power rule to each of the terms. So for item number 1, so I will just copy this one to make my life easier. Okay. So as mentioned earlier, when you integrate, you have to integrate term by term, and when you say integrate term by term, you're going to distribute the integration symbol and the dx for every term. So this is what I'm going to do. I will integrate 4x squared with respect to x minus the integral of 5x with respect to x and plus the integral of 8 with respect to x. Okay. Take note that in every coefficient that is present in each term, they have the freedom to go out of the integral sign and be written outside of the integral sign so that you will not have any complications in solving for the variables inside the variables in the integrand. So this can be written as 4 integral of x squared dx minus 5 integral of x dx plus 8 integral of dx. Okay, so I did it for the three terms. Now, since the integrand contains the variable to be integrated and the term and the power, so we can easily apply the power rule to each of the terms. So remember, now for the power rule, you just add the exponent by 1, divide the variable by the exponent plus 1, and then plus c. Let's do that one for the first term. We have 4 multiplied to the power rule, to the answer of the integral of x squared. So we have x 2 plus 1 over 2 plus 1 minus 5 multiplied by the integral of x dx. So we have x. So that it has an invisible 1 here. So we have 1 plus 1 over 1 plus 1 and then plus 8. Okay, now remember in my previous lesson that if the integral and the d will sit beside each other, they can actually be cancelled out. So that means if in this case the integral and the d are beside each other, then what is left is the x. So that means the integral of dx is automatically equal to x because of this concept. Okay, so what is left here is x. So please remember that one. So we have here always at the end of Integrating all of the terms, you add plus c. So to continue, we have 4 multiplied by x. 2 plus 1, that's 3, over 2 plus 1, that's 3. Minus 5 multiplied by x to the power of 2 over 2, and then plus 8x, and then plus c. So my usual style here is to group the numbers, okay, as a coefficient. So the coefficient will be 4 over 3 x cubed minus this one, 5 over 2 x squared plus 8x plus c. So 4 over 3 cannot be any more rounded to the lowest terms, and negative 5 over 2 cannot any more rounded off the lowest term. So dili na siya divisible. So that is your answer. Okay, that's your answer. Okay, for item number 2, so item number 2 kind of looks challenging or difficult, but what is actually tested here, so one of the things that you have to take note in integral calculus is it all boils down to your basic algebra skills. So what I'm going to write here, or one of my reminders here, is always, if you don't know what to do, what you can do, what you can try first, no? If ever you encounter a difficult item, is to do algebraic simplification. Okay? So when you say algebraic simplification, that means um, you need to find a way, or before you resort to a difficult technique in integral calculus, always think that what if it can be simplified, or what if I can just simplify the function in such a way that I will just make use of the power rule. So always resort to a always resort to a less sophisticated approach by doing algebraic simplification. So just power rule can do a lot of things. It's just that most students are overwhelmed with a lot of approaches that they think the basic integration is already or is not applicable. So always go back to the basics. And that one of the basics that we have to take note here is the algebraic simplification. So let's try to solve this one. So you might see this one as, oh, it's complicated. There's a square root of x minus 1, and then you multiply it with another x. Is there a better way to solve this? The answer is no. The only way to solve this is using the basic integration. So what makes this difficult is there's a product of two terms, the one outside and the one that's inside the parentheses. What you can do is actually just simplify it by distributing the x to the two terms in the binomial. So if you distribute it, if you multiply it, then you are left with only two terms to integrate. So for the first one, we have here the integral of x square root of x. So if you multiply x and square root of x, you get x square root of x. And then x multiplied to negative 1, that's negative x with respect to x. Okay. So now, how do we deal with x square root of x? So in this case, remember that the meaning of square root is basically power of 1/2, right? That's to the power of 1/2. So it also valid to say that x multiplied by x to the power of 1/2. Okay? So you need to apply your rules of exponents to simplify it further. So remember that x here has an exponent of 1, okay? Or it can be written in terms of fractions as 2 over 2. So of course, I need to use a fraction that has the same denominator as x to the power of 1/2, and that is 2 over 2. So according to the rules of exponents, if you multiply the same base with different exponents, these are added, right? This is a law of exponents. So If you're not familiar with this, you have to study laws of exponents. Okay? So now, if I have this one, then the product of x squared of x is, or x squared of x can be rewritten as x to the power of 3 halves. So 3 halves is the sum of 2 over 2 plus 1 over 2. Okay, so I hope that's clear. So again, in integral calculus, the roots or the square root symbols or the root symbols are not useful or not helpful as far as getting the integral is concerned. So you need to convert everything in terms of actual exponents. Okay? So regardless if the exponent is a fraction or not. So we have here the integral of x to the power of 3 halves minus x with respect to x. So again, we have two terms here. So we have x to the power of 3 halves and we have x, negative x rather. So I'm going to integrate it term by term. So we have integral of x to the power of 3 halves with respect to x minus the integral of x with respect to x. So let's apply power rule. So there are no coefficients to bring out of the integral, so we can solve it directly. So this is power rule. We have x to the power of 3 over 2 plus 1 over 3 over 2 plus 1 minus x. There's an imaginary one there. Not imaginary, invisible one. Okay, that's a mistake. Okay, and then you need to add plus c. So what is 3 halves plus 1? 3 over 2 plus 1 is just like saying 3 over 2 plus 2 over 2. So I'm basically copying the denominator to make it easy to add. So 3 plus 2, that's 5. So basically, the first term will be x to the power of 5 over 2 over 5 over 2 minus x to the power of 2 over 2 plus c. So again, this is actually a fraction of a fraction. So if ever you have this one, 5 over 2, remember in your basic fractions, if you have 1 divided by a fraction, then basically you are looking for the reciprocal of that fraction. So you just flip the 5 over 2 and make it the coefficient of your x. So that becomes 2 over 5 times x to the power of 5 halves over. So we have here over 2. So there's an invisible 1 there. You can make that one as the coefficient. So that's 1 over 2 x squared plus c. Okay, very easy. Those are very basic examples. Okay. My last example is this one. It's a definite integral because it has an upper and lower limit. Okay. Now, what am I going to do with this one? So again, in solving for the definite integral, for an integral that is definite with the upper and lower limit, so we call this one as the lower limit, and we call this one as the upper limit. So what to do or how to solve this one is first, solve it as if it is an indefinite integral. Indefinite integral. And then the second one, after you solve it as if it is an indefinite integral, you apply the limits by using the Fundamental Theorem of Calculus. So you apply the fundamental theorem of calculus. So I will show to you later. So let's solve it as if it's not an let's solve it as if it's an indefinite integral. Okay, apologies. So we have integral of 5x to the power of 2/3 plus 3 over x squared dx with respect to x. Okay, now, sir, we have a fraction here that's over x squared. So how do we deal with that? So again, in integral calculus, it will be difficult to treat a term that has denominator, no? Because we don't have what we call a quotient rule in integral calculus. What you can actually do with that, since this is a very simple case of a denominator that is just one term, it's a monomial, right? It's not x squared plus 1. Because if it's x squared plus 1, then that will be complicated. But it's just one term. So what you can do is to use the rules of exponents, wherein if you flip this one, 1 over x squared is like saying x to the power of negative 2. So this is index laws or law of exponent. Remember that one. So if you remember that law of exponent, you can actually rewrite everything in such a way that you will get rid of the denominator and you will just multiply x to the power of negative 2 beside 3. So in this case, it will become integral of 5x to the power of 2/3 plus 3x to the power of negative 2. And then with respect to x. So simple. You don't anymore have problems with the denominator since you just applied the law of exponent to get rid of the denominator. You just flipped it or get its reciprocal. So again, you solve it term by term. 5x to the power of 2, 3. Make sure that you distribute both the integral sign and the dx to each of the terms. And then what will happen is the coefficients have the freedom to come out or to go out of the integral to help you simplify your approach in solving it. And you can easily apply the power rule if you are going to do this. So some quick students, they do not anymore put this line, no? Pwede naman mo, you can just do the shortcut for this one. But of course, for beginners, I want you to show it in the solutions na you're really doing this process na you're uh, placing the coefficients outside. So what happens next is you're going to apply the power rule. So that will be x 2 over 3 plus 1 over 2 over 3 plus 1 and then plus 3 times x negative 2 plus 1 over negative 2 plus 1 and then plus c. Okay, so let's apply what is 2/3 plus 1. That's basically 2/3 plus 3 over 3. So adding fractions, 2 plus 3, that's 5 over 3. So we have 5 times x 5 over 3 over 5 over 3 plus 3 times, what is negative 2 plus 1? So negative 2 plus 1, that's equal to negative 1. So you have x negative 1 over negative 1 plus c. Okay. I think I have a mistake here. You do not need to write any more plus c because we are going to substitute the upper and lower limits later. So again, my mistake. No need to substitute plus c. Next, you're going to get the reciprocal of this one. So there's an imaginary, invisible one here. So basically, the 1 over 5 over 3, that's basically 3 over 5, right? The reciprocal. And then you multiply the 3 over 5 to the coefficient outside. So that becomes 5 times 3 over 5 x to the power of 5 over 3. And then plus 3 over negative 1. 3 over negative 1, that's actually negative 3. So that becomes negative 3. So you can immediately write the negative sign right away and then multiply it with x negative 1. Okay. So you multiply it. So 5 times 3 over 5, it actually cancels out. So you have 3x 5 over 3 minus 3x to the negative 1. Okay, the next step is the x negative 1 is just equal to, by virtue of index laws, that's saying 1 over x to the power of 1. Or just basically 1 over x because the 1 there is invisible. So, you solve it, it becomes 3x to the power of 5 over 3 minus 3 times 1 over x. Or basically, you can write it as 3 over x. There. Now, you're done doing the indefinite integration. You are now ready to do the fundamental theorem of calculus. So you're going to apply the lower and upper limits for this case. So how to do it? You just write here the lower limit 2 and apply it by 3. So the fundamental theorem of calculus states that for whatever function you have here, you substitute it with a upper limit. This is the b, and minus it from the answer of the function substituted with a. That's the fundamental theorem of calculus. So you're going to substitute. So you have 3 times, okay, put the upper limit here, the 3. So 3 to the power of 5 over 3 minus 3 over 3. And then minus the same function again, but this time use the lower limit. So we have 3 times 2 to the power of 5 over 3 minus 3 over 2. And then that will be your answer for the definite integral. So I'll solve. Oops. 5. Oops. What is happening to my calculator? Minus 3 over 3. Okay. Minus. So I'm just typing everything in the calculator. So if you want to type in the answer for each of the term, like you want to write the answer of this one minus the answer of this one, it's okay. But I just to simplify my process of writing it. So my answer is around 9.6963. So I hope we have the same answer. So I think that's it for my examples. So that will suffice for now, and then I will give you some assignments so that you can further practice on more examples for basic integration. All right, that will be all for now. Thank you so much, and I will see you in my next video.